Hi everyone. In the motivational video, we have discussed about one simple problem. The fluid was steam. In that video, I also told that if you replace steam by any real gas or any other ideal gas, then how you are going to solve that problem, because steam, in case of steam, we can use steam table, but in case of real gas, in case of real liquid, there are not such tables available. For that, we have discussed that we should develop a models that can relate measurables like temperature, pressure, volume, heat capacities to those properties like internal energy, enthalpy, Gibbs free energy, and all other properties. We are going to develop such relations. Okay. Now, what is the methodology? If you see chemical engineering thermodynamics, then what should be the methodology to solve any problem? In most of the cases, in industrial problem, we are going to deal with heat transfer and work interaction. As for example, in case of pump or any compressor, we are going to calculate how much work is required, or in case of turbine, how much work it will produce. In case of refrigeration, how much work is required, or how much heat should be removed from any reactor, or how much heat we should add in any reactor. We are going to deal with heat and work interaction. Let's consider that for any process, we have to develop any relation, or the objective is to calculate Q and W. Find Q and W for any process. This is our objective. We want to calculate Q and W for any process. Now, what are those ways? Using first law of thermodynamics, delta U equal to Q minus W. Using second law of thermodynamics, this is a statement of second law of thermodynamics. This is a statement of first law of thermodynamics. If I want to calculate Q and W, then I should know the value of delta U and delta S. Delta U is changes in internal energy, and delta S, that is changes in entropy. These U and S are not directly related to any measurables. Which are measurables quantities like temperature, pressure, volume, heat capacities. These are measurable quantities. You can measure by experiment. But this we can't relate directly to any this quantity. If I'm not able to calculate delta U by experiment, if I am not able to calculate delta S by experiment, then I can't calculate Q and W. What is other option? So this is the first step, first objective. To solve this objective, we have written the equation, relate first and second law to calculate delta U and delta S. I'm sorry, to calculate Q and W. Okay, but I am not able to do this Q and W using first law. This cannot be measured directly. So what I can consider, there are two options: relate delta U and delta S to measurables. That is one option. If you have an equation, you can just relate delta U and delta S to measurables quantity, and then calculate Q and W. Because if you know the values of delta U and delta S, then you can calculate Q and W using these two equations. Okay, but this is not possible because we can't relate delta U and delta S to measurables. The other option is you can relate delta U and delta S to new conceptual. Means the new property like Gibbs free energy, enthalpy. If you can relate these two to new properties such as enthalpy, Gibbs free energy, and those new conceptual relate this new conceptual to measurable quantity. This is the next step. When you relate delta U and delta S to new conceptuals, then relate these new conceptuals to measurable quantities, and then the last step, when you relate this, find changes in U and S using these new conceptuals, and those changes then can be used to calculate Q and W. So this is a methodology. In any problem solution, we have to calculate in real problem. Ultimately, the objective is find out what is the heat transfer, find out what is the amount of work interaction. But for that, to calculate Q and W, you should know various quantities. If those are measurable, that is good thing. If those are not measurable, you can't measure by experiment, then relate with any other quantity that can be measurable. This is the methodology to solve any problem, to develop, and this is the motivation for the development of fundamental property relations. Means we are going to develop relation among delta U, delta S, other properties like Gibbs free energy, enthalpy, then Helmholtz free energy. Now we are going to develop those four fundamental property relations for closed system of n moles. And also the process is reversible. The first law of thermodynamics can be written dnu equal to del q minus del w. But for reversible process, del q equal to PdNs and del W equal to PdNV. If I put these two values in this equation, it would be PdNs minus PdNV, and here is the number of moles. If I want to write this equation for 1 mole, I mean n equal to 1, then equation would be du equal to T ds minus PdV. This is the first fundamental property relation. I have written this equation U as a function of two canonical variables S and V. These two are differential variables. Okay. If I want to write the equation for H according to the definition of enthalpy, H equal to U plus PV, dH equal to du plus dPV, du plus PdV plus VdP. Now I can replace this du from equation 1. It is TdS minus PdV plus PdV plus VdP. these two terms will be cancelled and dH equal to TdS plus VdP. This is second fundamental property relation. So here enthalpy is a function of two canonical variables S and P. Okay, now the other important properties are Helmholtz free energy and Gibbs free energy. What are these properties? Please check the other video of thermodynamic potential. I am writing the definition of Helmholtz free energy, that is A equal to U minus Ts. So if I want to write this equation in differential form, then dA equal to du minus TdS minus SdT. Now I can replace this du by equation 1. It would be TdS minus PdV minus TdS minus SdT. These two terms will cancel and ultimate equation would be minus PdV minus SdT. This is third fundamental property relation. Helmholtz free energy is a function of two canonical variables V and T. Fourth property, that is G, and this is very important for chemical engineering thermodynamics. G equal to H minus Ts. If I want to write this equation in differential form, dG equal to dH minus TdS minus SdT. We can replace the value of dH by equation 2. So TdS plus VdP minus TdS minus SdT. These two terms cancel and dG would be VdT minus SdT. This is fourth fundamental property relation. I can write all this as a U from equation 1. U can be a function of two variables, U as S and V. H is a function of two canonical variables, S and P. A is a function of two canonical variables, V and T. And the last is G, is a function of two canonical variables, P and T. These four are fundamental property relations. We can relate any property with some canonical variables. Now, we have derived these four equations, but I have some questions for you. There are four equations. Which is more fundamental? Is it any fundamental equation or all are equivalent? That is the first question. The second question is why each property is written as a function of two canonical variables? That is the second question. Why each property is written as a function of only two canonical variables? That is the second question. Third question, why U is written as a function of S and V? Why not other two parameters like V and T? Can I write, just for example, can I write U as a function of V and T? Why here it is written U as a function of S and V, while G as a function of P and T? Means why the specific set of variables have been selected in any property? That is the third question. You can answer these questions. You can think critically, try to answer those questions. For the solution, please watch next video. Thank you. Thanks for watching this video.